Okay, so here we're going to talk about section 3.8. So before we get into what it is, let's check out this first example. So it's very similar to what we were doing in the previous video, right? We're trying to find the equation that best fits this data here, and then we're looking at the graph, right? So if you remember last time, right, we were talking about this linear one, right? So last time we were given these points here, and we saw that when you plot these, it made a nice line. You connect them, you can extend it backwards, you can extend it forward, and then the bigger point is we saw how the data points created an equation, and then we saw how the graph worked. So we saw how all three of these were kind of related to each other. That's kind of what we're going to do here, but right. So looking at these points here, 0, 1, 2, 3, 4, 5, but see the outputs here, 3, 6, 12, 24. Uh-oh, they are changing a lot faster. So if they're changing a lot faster, we're thinking hopefully not an arithmetic sequence, but this is more like that geometric, right? Because see, like could you add something to 3 to get to 6? Sure, you could add 3, but if you added 3 to 6, you're not going to get 12, right? So you're definitely not adding the same number over and over again, right? Because the previous one, right? Remember, we went from 1, 3, 5, 7. See how you keep adding 2? That adding 2 was what made it a perfect line. That's what was talking about the slope, right? Here, we are not adding the same number. Oh, we are multiplying, right? So you're multiplying by 2, right? And that's what's creating these numbers, right? So you can see, like if you started with the 3 and you multiplied by 2, that's where you're getting the 6. And then multiply that by 2. There's the 12, 24, 48, 96, right? So you keep multiplying by 2. Okay. So this is definitely that more geometric feel, right? Or if you guys remember, that's that. In this case, you like the 0 here is the 3, right? And you're multiplying by 2 over and over again. Okay. But again, it has that same starting somewhere feel. And then instead of adding, you're multiplying by something. But that repeated multiplication, that's what turns it into a power, right? That's what's giving you your output Y. Okay. All right. And even you can even kind of see it like, so like if you did 3 times 2 raised to the, let's say, 4th power, right? So if I plug in 4, sure enough, it's giving you the 48. Or if we did 3 times 2 raised to the 5th power, sure enough, it's going to give you 96, right? So this equation is modeling this situation, just like we did before, okay? The newer part here is what the picture is going to look like, okay? Well, let's look at these points. So we got 0, 3, 1, 2, 3 would be here. Then when you have 1, you're going to go 3, 4, 5, 6 would be up here. Then 2, you're off the chart, okay? So it's way up here, okay? So it's kind of hard to draw that. But the point is, see how like this would be a line going like this, but 312 is way past that line, right? So you kind of want to visualize if it were a line, it would be here. So when we were 3, we should be there, but it's really way up there. So it's not going to be a line anymore. Okay. What I think might be helpful to see here, see how the height here is 0, 3. That's this height here. So if you were to double that height, see like here's 3, but if you double that, right, taking this and doing 2 of them, that's what's creating this height. So the next one, see, it's going to be this high, right, which is 6, but it's going to be twice as big as that. So now the next one, 1, 2, 3, 4, 5, 6 is way up there, right? Then this one here, see how this is this height here? You're going to take that height and you're going to double it, right? So you're taking this and you're going to go way up there, okay? But it's way up there, okay? And that's what's creating these points, right? So at 0, you're at 3. At 1, you're at twice as high, 6. At 2, you're twice as high, 12. At 3, you're twice as high, 24. So it's creating more of a curve to it. Okay. Before we connect those with what's happening here, what I might want to talk about, or we should talk about, is what's happening the other way. Okay, hold on. Let me go back. So remember when you're talking about adding one, remember where, like if you were talking about a linear one, you kept adding, right? So we would go up by adding. But if you were to go backwards, then you would start subtracting, and that's what's causing it to go down. Adding is what's causing it to go up. Subtracting is causing it to go down. So it's kind of the same thing here. If you think about it in the terms of this direction here, you keep multiplying by 2, right? Every time I go up 1 here, every time you go to the right here, the outputs are getting multiplied by 2. So the question is, what happens if you went the other way, right? So now if x were -1, if x were -2, if x were -3, if you were to go the other way, what would you do? Well, stands to reason here, if this were adding and you go backwards, you would do the opposite, subtracting. This one, if you go forward, you'd be multiplying. So if you were to go backwards, the opposite of multiplying would be you would be dividing by 2, right? So if it's 0, you're supposed to be at height 3. Then the next one to the left, you should be dividing by 2, right? So it should be 3 divided by 2, which would give me 1.5, right? But then I'm going to divide that by 2, which would be 0.75. Then divide that by 2, but that's going to give you, let me write somewhere, 0.375. And then divide that by 2, 0.1875, right? So think of it picture-wise. See how this is at height 3? Okay. So when I go this way, instead of doubling it, I'm going to cut it in half. That's why you're only up half as high, right? So you kind of visualize this stick here. If I only took half of that stick, that's why you're right here at 1.5. Right? That's going to give you that height. Okay. Then you're going to take that and cut it in half. Well, half of 1.5 is down here at 0.75. Okay. Then the next one is half as high as 0.375. The next one is half as high. The next one would be half as high, but it'd be so small, you're basically hovering, right? So you see what's happening is you take this and you keep dividing by 2, right? You're going to get smaller and smaller and smaller and smaller and smaller numbers. But notice, none of them are negative. So you're not going to dip below down here into the x-axis, right? Because if you went down here, you'd have negative numbers, but you're not. You're just getting really, really, really close because this is so small, right? And that's why the graph is going to have this shape, right? So this is the shape of these exponentials. So think one direction, it's going to be shooting up really fast. The other direction, it's going to be flattening out, right? So if the number that you're multiplying by here is big like this, you're going to multiply up this way. And the other way, you're going to be dividing by it. That's why it's going to flatten out, right? Okay. Let's check out a different example. But one thing to notice, see, like as the x's are getting bigger, see these are getting bigger. So it definitely seems like you're multiplying by a big number here. All right, same idea, just a different example. Here's 0, 1, 2, 3, 4. But look at your numbers. Your numbers are now getting smaller. Okay. So think of it as here's 0, 1, 2, 3, 4. Now, when I go to 1, you're only at height 2. When you're at height 2, you're only at height 1. When you're at 3, you're at 0.5, right? So what's happening here, hopefully you can see, is now instead of multiplying by 2, now you're dividing by 2, or you're cutting it in half, okay? So the equation here, you could think of it as, again, you're starting with 4, you're dividing by 2 a bunch of times. Or you can think of it as you're multiplying by something over and over again. It just happens to be a fraction. So whether we want to think of it as dividing by a nice number or multiplying by a fraction, a half, you're cutting it in half. Okay. And that, if you know, 0, 4, 1, 2, 2, 1, 3.5, 4 would be 0.25. But the point is you kept going, it's going to get closer and closer and closer, or it's going to hover this way, right? Because see, like you can start, again, you can see on the calculator, if you took 4 and you divided by 2, right? And then divided by 2 again, right? That's what's giving you 1, then 0.5, then 0.25. But you see what's happening if you keep doing that? It's getting smaller and smaller and smaller, and that's why it's, you know, getting closer this way. Okay. So if this direction, you could think of it as division, then that means the other way you would be multiplying, right? So if this were 4, if this direction you're multiplying, the opposite, you should go the other way. So that means you would be multiplying by 2, which would be the 8 then. And then multiply that by 2 would be 16. Multiply that by 2 would be 32, right? So going the other way, instead of dividing, you are multiplying by 2. Multiplying by 2. Oops, but hold on. Right, 4 times 2, there's your 8. Multiplying by 2, there's the 16, there's the 32, and it keeps getting higher. But now the point is it's getting higher the other way, right? Because here at -1, you'd be up at height 4, 5, 6, 7, 8. And then you'd be twice as high. You're way up here at 16. But that's what's creating this basically the same shape, but it's the other way. Right? So you can kind of see they both have that feel of one direction it shoots up and the other direction it flattens out. Okay. Hopefully, you can also see it with the fractions, right? So going this way, if you think about it as multiplying by half, so you're doing 4 times, a half or 0.5, if you like. That's what's creating the 2, and then you're multiplying by a half. That's what's creating the 1, then 0.5, right? And also, it helps to talk about if you're multiplying by half this way, you're dividing the other way, right? So it's 4 divided by a 0.5, right? But again, that's what's creating 8. And then if you divide by another 0.5, that's what's creating 16, and that's what's getting higher, right? So the basic punchline is this. You have these two basic shapes here, okay? If we think about it as multiplying by a big number, it's going to shoot up, and then dividing by a big number is going to flatten out, okay? But if we think of it as multiplying by a fraction, it's going to flatten out this way, and then dividing by a fraction is going to cause it to shoot up, okay? So that's kind of the general idea here, okay? So anytime you see an exponential, this is that crazy formula, but it's y equals a times b to the x, right? Don't get lost. Think y equals blank times blank raised to a power, right? So that number out front, that's kind of like your starting, and then we keep multiplying by something over and over again. That repeated multiplication turns into a power, right? Very similar, yet different, but it is similar to what we were doing before. Remember the line stuff we were doing previously? The general idea here is, remember the line was y equals mx plus b. So you're starting with a b, that's your y-intercept, and then you keep adding something over and over again. That repeated addition is your slope with the number times x. It's basically the same thing here, but think this is your start, right? Wherever you're starting with, and then you're going to keep multiplying by something over and over and over again. That's the thing with the power on it, right? And basically the point is, if that number you keep multiplying by is bigger than 1, you're going to have this shape, right? Because if it's, think this is like your start here, right? You're always going to start at that y-axis. This is your start on the y-axis, right? If the number you keep multiplying is bigger than 1, that's what's going to cause it to shoot up, right? But if you divide by it, that's what's going to cause you to flatten out. If your number is smaller than 1 or a crazy fraction, when you multiply, that's what's going to cause it to flatten out. But then dividing by a fraction is going to cause it to shoot up, right? Okay, so let's check this out. So I'm going to give you an exponential function. You have to decide whether it's a growth or decay, state the initial value, what's the multiplier, and then the hard part here is the rate of change. And then we can check out some points. Okay. So I think it's probably easier to start here, right, with the initial value. Because see, like what you're think of it as there's a number, and then you're going to keep multiplying by something over and over and over again. So what you're starting with here is 3, right? Or think 0, 3, that's your y-intercept, right? The number without the x on it, that's where you're starting at, right? Because if x were 0, that wouldn't be there. Oh, look, you started with 3. Okay. Then this exponent says, hey, I'm going to keep multiplying by 1.2. So that's what you're using as a multiplier, okay? But here's the thing. If you looked at the numbers, so if I started with 3, you're going to multiply by 1.2, right? Then you're going to multiply by 1.2. But the point is you're going to keep doing that. But see, look, the numbers are getting bigger. Not that they're getting longer. I don't care about that. I'm talking about the decimal, right? Let me go back. 3 times 1.2, right? This is 3 something. It's bigger than 3. Multiplied by 1.2 is now 4 something. Now it's 5 something, 6 something, 7 something, 8 something, right? It's getting bigger. So multiplying by 1.2 is going to cause it to shoot up, okay? As a matter of fact, let me go back. 3 times 1.2, that's going to give you 3.6. That's why here would be 3.6, right? Somewhere between 3 and 4. And then multiply that by 1.2 is now going to be a little bit above 4, right? 4.3. And then do that again. Now it's 5 something. It's a little bit above 5. Do it again, a little bit above 6. Do it again. Now it's a little bit, basically between halfway between 7 and 8. And then do it again. Now it's up here at almost 9, right? But you see how it's shooting up? If you were to go the other way, go back to the 3, but now you're dividing by 1.2, right? So now it's only at 2.5. Then divide that by 1.2 because you're going backwards now. Now it's going to be just barely above 2. divided by 1.2 is between 1 and 2. Do it again. Halfway between, roughly, that's 1.5 roughly, so it's halfway between 1 and 2, roughly. Still above 1, just barely above 1. Now we find it's crossed over in below 1. And then that's when it's going to start to hover down. But again, that's the point here is starting with 3, multiplying by something that's bigger than 1 is going to cause it to shoot up. Then the other direction, you're dividing by something, that's what's going to cause it to flatten out, right? But it has this basic shape, right? One direction is shooting up, the other way is flattening out, which is going to be a growth, then reading left to right. But here's the key. How do you know that it's growth? As long as this number is bigger than 1, right? 1.2 is bigger than 1. It's greater than 1. Multiplying by something bigger than 1 is going to cause it to shoot up. And backwards, dividing is going to cause it to shoot down. Okay. The hard part is the rate of change. Okay. So you got to go back. Remember percentages, right? So if you're multiplying by 1.2, maybe we can go on the other side here. Remember what 1.2 means? 1.2 is the same as 120%. Right? Remember that when you stick that 1 out front? This means you are increasing something by 0.2. Or in other words, you are increasing by 20% because it's 100% more. So 1 is, it's all about that same trick. Right? 100% is 1. That's the same. Anything that's 1 point blah, or it's something is 0 point blah, whatever, or what I shouldn't do it. I don't know what it is, right? But if it's 0 point something, basically if it's above 1, you've increased. If it's below 1, it's a decrease. However far above 1, that's how much you've increased. However far below, that's when you've decreased. So this 1.2, right, is basically 20% higher than it was. That's basically, it's above 1. Okay. And picture wise, you can kind of imagine what that's saying. You see, like, here's how high this is. Over here, if I took all of that, see, you're adding 20% more, right? And if I took that same thing over here, now I'm adding 20% more. Take the same thing over here, you're adding 20% more. Same thing over here, you're adding 20% more, right? You're taking that same height over here, you're adding 20% more. All right, so let's try this one. Now, once you get used to this, hopefully you can see, oh, look, this number, starting with 4, that's my initial without the x. The thing we keep multiplying by is 0.7, but that's less than 1. That's why this is going to be a decay, right? Because your 0.7 is less than 1, okay? But the question is, how far is that less than? Well, think about 0.7 is the same as 70%, right? 100% minus 70% is 30%. So you're losing 30%, or in other words, there's a 30% decrease. Okay, that's the rate of change. So again, it's all about that 1, right? If the number is greater than 1, how far above 1, that's how much you're increasing by. And however far below it is 1, that's how much you're decreasing by. Right? In this case, 0.7 is the same as 0.3 less than 1 or 30% less than 100%. Okay. But the bigger point here, you can see the 4 would be there. Okay. And now going this direction, you're going to be multiplying. But if I take 4 and multiply by 0.7, see, you're only keeping 70% of it. That's why it's now at 2.8, which is between 2 and 3. And then you're going to keep multiplying by 0.7. Now you're 1.96. Multiply again, 1.3, so it's a little bit above 1. And then multiply again. Now you're below 1. Do it again. You're down here, down here, down here, down here, right? But if you keep doing that, it's getting lower. But if you go the other way, instead of multiplying, you're now dividing. So now if I go back and divide by 0.7, oh, see, now it's way up here at 5 something, almost 6. And then divide by 0.7. Now it's past 8. So I'm already up here. And see, that's the whole idea. Since this number is less than 1, this direction it's going to flatten out. And the other way is what's going to shoot up, right? So anytime that number you keep multiplying, it's less than 1, right? Then what you're talking about is this direction flattening, and backwards causes it to shoot up, right? All right. So the other thing, putting this all together now, is if I give you these charts here, right? I want to determine if the given set of points represents a linear or exponential relationship. Then find the equation that best represents the data. Okay. So just by looking at the charts, we want to tell me, kind of putting the ideas together, the linear versus exponential, and then be able to come up with the equation for it. Okay. So kind of what you want to do is you want to imagine, hold on. This is what we're just talking about with the exponential. And before we were talking about a line. So think of a line, right? The general idea here. Right? So remember this whole slope-intercept form. So it's y equals mx plus b. But you want to imagine if the line goes up, your slope is positive, right? That's what we were doing before. And if your line goes down, the slope is negative. Okay. So if we know the line goes up, it's positive. If we know the line goes down, it's a negative slope. Okay. But it's steady. It's relatively slow. When you see exponentials, think fast, right? It's either shooting up really fast or shooting down really fast. Okay. So kind of like a holistic big picture approach. Like if you look at these kind of charts together, see like the outputs are all over the place here, right? But see, they're going up, but not that fast. Here they're going up, but really fast, right? Here they're going up, but not that fast, right? Here they're going down, but they're going really fast. Okay. So kind of what you want to be thinking is, well, this doesn't look like it's changing very much. So if it's not changing very much, we should be thinking linear. This one changes really fast, exponential, right? This one changes kind of slow. So again, probably linear. And this one is changing really fast, exponential, right? Now we can go back and nitty gritty this. Okay, so if this is changing relatively slow, we should be thinking linear. All right, so once you're in the linear world, you want to think y equals blank x plus blank, right? mx plus b. So anytime you have a linear, we need to find the slope and we need to find the y-intercept. Okay, great. So let's find the slope. Well, in order for to even be linear, the slope, remember, what makes a line? The slope has to be the same throughout. Or we're in this adding world. Okay, well, let's check this out. From -2 to 10, so you went up 12, right? A negative to get to 0 is 2, and then to get to 10 is 10 more. That's why I went up 12. 10 to 26, it went up 16. 26 to 46, it went up 20. So is it going up by the same amount? No. But wait a minute. Before, remember when we were doing the line? This was easy because it was 1, 2, 3, 4. All of the numbers were there. And it was easy to see what these were going up by. The problem is here, these inputs are all over the place, right? It's not, basically it's skipping. See, it's 2. I don't know what 3 is. I don't know what 4 is, but I know what 5 is. 6, I don't know. 7, no. I don't know. 8, I don't know, but I know 9. 10, 11, 12, 13, 14. You see that? It's jumping. So you have to figure out the runs as well, right? See, these are the rises, but 2 to 5, sorry, it's 3. 5 to 9 is 4. 9 to 14 is 5. But here's the point. If you compare the rises to the runs, 12 divided by 3, 16 divided by 4, 20 divided by 5. Well, wait a minute. 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 5 is 4. They're all the same comparison, right? Again, your rises might change, your runs might change, but the comparison is the same. That's what makes this linear. So now that I know the slope is 4, I know what should sit here. But I don't know what the y-intercept is. You could go and figure it out from the chart, or the easiest way is just pick a number, right? So if I just pick this point here, let's just say you pick 2, -2. Okay. What this is saying is if you plug 2 in for x, you better get -2 out for y, right? So 4 times 2 plus this magic number b better give me -2 out, right? Plug 2 in for x, plug -2 in for y. We need to figure out what this number is to make that happen, right? So this is -2. Oh, 4 times 2 is 8 plus b. You could just think about it. If I started with 8, what would you have to add to get back down to 2? -10. Or you could think of like an equation. Oh, I got to subtract 8 to get the b by itself. So then b would be -10, right? Which basically means that b would have to be -10. So we are talking about y equals 4x minus 10. That would be the equation. You don't have to, but I would highly recommend check it out. Pick one of these points. Heck, you can pick them all because it's not that hard to do, right? So what this is saying is if I took 4 and multiplied by the x value, 2, no, 2, right? And then subtracted 10, right? So you're plugging in 2, 4 times 2 minus 10. Sure enough, it gives me negative 2. You could go back and try 5, right? If I plugged in 5, sure enough, it's getting me 10. You could go back and plug in 9, right? 4 times 9 minus 10. Oh, look, 26, right? And plug in, what is that, 14? Sure enough, 46. It's working. That's the point. Okay. Now, once you see something like this, I'll see how it's growing really fast. You should be thinking exponential. Okay, so now once you know you're in the exponential world, you should be thinking y equals blank times blank raised to the x, right? So I need to know where it starts, and then I got to figure out what it is that we're multiplying by. Okay. Well, again, also notice these x values are all over the place. But one thing you might say, okay, so that means if I'm in the exponential world, that means I had to be taking 48 and multiplying by something to get to 768. So 48 times, blah, had to give me 768. Well, you could figure that out backwards by taking 768 and dividing by 48. So that means I multiplied by 16, right? So sure enough, if I took 48 and multiplied by 16, that's going to give you 768. Okay, so you're thinking I should multiply by 16. So if I keep multiplying by 16, that's not giving me this one. Okay, so what's going on? Oh, wait a minute. I'm jumping, right? So especially with the exponentials, what I would highly recommend is fill in the gaps. What I mean by that is 248 was given. When x is 3, they didn't tell me what it was. When x was 4, they told me it was 768. 5, they didn't tell me. 6, they didn't tell me. But when I get to 7, I should eventually get to that 49152. Okay. See, I'm doing those, just filling in the gaps, right? They told me 2, they told me 4, they told me 7. Yeah, they told me 10, but they'd be down here. We'll get to that. But fill in the gaps. What would it be at 3? What would it be at 5? What would it be at 6? Okay. But what did we do here, right? We figured out you could have taken 48 and multiplied by 16. Okay. But that means you had to have taken something twice to get to there, right? Because to be an exponential, you have to keep multiplying by the exact same number over and over and over again to fill in these gaps. But if you jumped from here to here, you multiply by 16. That means there's got to be some other number that would behave the same way. Or in essence, I'm looking for 2, multiplications to give me 16. So what number times itself is 16? 4 is, right? 4 times 4 is 16. So what that means is I really had to have multiplied by 4 and then multiplied by 4 again, right? And you can check it out. So 48 times 4 would be 192, right? But if I take 192 and multiply by 4, oh, sure enough, there's the 768, right? And if you keep doing that, if you multiply that one by 4, there's 3072. If I multiply that by 4, there's 12288. And if you multiply that by 4, sure enough, there's the 49152. Okay. And heck, you could even keep going if you wanted. So this would have been 7, 8, 9, 10. And sure enough, when x is 10, we're getting that same number. See that 3145, 728? So what does that mean? We keep multiplying over and over again by 4. Okay. Now you got to figure out what the initial was. But remember, the initial is all about that y-intercept, or when x is 0. Well, basically you got to figure out what it is. But this direction, you see how you're multiplying by 4? So it's kind of that same picture. If one direction you're multiplying by 4, to go backwards, that means you would have to divide by 4. Oh, okay. So I can go back when x is 1. You can go back here. 48 divided by 4 is 12. And then if you divide that by 4, you're going to get 3. So that means my initial right here, when x is 0, that initial had to have been 3. So there's your actual equation then. And again, you could check it out, because if you did 3 times 4 raised to the 2, for example, sure enough, it's giving you 48. If you did 3 times 4 raised to the 4, sure enough, it's giving you 768. Or 3 times 4 raised to the 7, it's giving you that number. Or raised to the 10th, it's giving you that number. It's working, right? So kind of the big picture here is once you realize you're in the linear world, figure out what the slope is, go back, figure out the y-intercept. Once you realize you're in the exponential world, I would highly recommend fill in all the gaps so that you can figure out what your base is, what your thing you keep multiplying by, and then keep doing that until you get back to zero if needed to figure out where the beginning is, right? All right, so let's check this out. All right, so this one here again, 10, 13, 19, 34, it's not going very fast, so you should be thinking linear. But wait a minute, these are all over the place, right? So you can't just look at it and see. You got to figure out, okay, this is going up by 3, this is going up by 6, this is going up by 15, right? You'd have to add 3 here, add 6 here. That one maybe you need a calculator on, but whatever. 34 minus 19, sure enough, it's 15. So would have added 15, right? From 4 to 8 went up 4. 8 to 16 went up 8. 16 to 36 went up 20. Okay. So that means the slope here would be, your compare would be 3, 4, 6 over 8, 15 over 20. Now I know nobody likes fractions, and they say, okay, well, what is this? Well, what is 3 divided by 4? Oh, you get 0.75. What is 6 divided by 8? Oh, you get 0.75. What is 15 divided by 20? Oh, you get 0.75. But the point there is they're all the same comparison. So what does that mean? We are indeed linear, right? So you should be thinking y equals blank x plus blank, where we just figured out my slope is that same. If you want to use the decimal version here, you can, okay? But 0.75, that's tricky, right? Because what 0.75 really means is you're comparing 0.75 to 1, right? Especially when you go to the graph of these things, that's kind of annoying to work with. You don't have to, but what I would recommend is going with the fraction that's the simplest to work with. See, like all of these would reduce to 3/4, right? Get rid of a 2, get rid of a 5. They all reduce to 3/4. Okay, that might be easier to work with. So that means your slope is 3/4. But the y-intercept, I don't know. Okay, so what you can do is just pick any point you want here and try to figure out what b would make that work. I don't know. Let's pick the first one, right? So let's just say we picked 4, 10. So what this is saying is if I took 3/4 and multiplied by the x value, which is 4, I'm trying to figure out what would this magical b be so that I'm guaranteed 10 out. Right? I know, everybody picks up a calculator. All right, so I got to do 3/4 and then multiply by 4. But oh, look, you're left with 3, right? Duh, because you divide by 4 and then multiply by 4, they're going to cancel each other. So you're just left with 3 plus b equals 10. Again, just think 3 plus what number is getting me up to 10? 7, right? Or you could think of it like an equation, so I'd have to subtract 3 to make this go away. But sure enough, 10 minus 3 is 7. So b is 7, which means your actual answer here would be y equals 3/4 x plus 7. Right? There's your equation. Right? Again, it couldn't hurt to check it, right? See, 3/4, we're supposed to be multiplying by something and then adding 7, right? So let's just plug in one of these points. So let's say I were to insert 36. Sure enough, it gives me 34. Or if you were to go back and plug in 16, right? No, 16. Right? 3/4 times 16 plus 7. Sure enough, it's giving me 19. It's working. Right? All right. Last one here. All right. See the numbers here, 2081, 9.3. They are changing really fast. So we should be thinking exponential. So we should be thinking y equals blank times blank raised to the x. Now you could do it this way, or wait a minute. It's not going like this one was exponential, but see how it's going up, right? That's where we're multiplying by a number bigger than 1. These are going down. So you could do this. It's a multiplying, but then it would have to be some sort of fraction, right? Because it's got to be less than 1. Or you could think of it as you're dividing by something over and over again. It's up to you, right? If you want to think of dividing by a big number or multiplying by a fraction, whatever. Honestly, you should be able to see both, right? But to figure out what that is, wait a minute, right? There's gaps here. So you might want to figure out the gaps. So what I mean by that is, so like 2, they told me was 2187. 3, they did not tell me. 4, they did not tell me. 5 was 81. 6, they didn't tell me. 7, they told me was 9. And we're already here most of it. So 8, I don't know. 9, I don't know. But 10, they told me was that 0.3 repeating. Right? Okay. So, I mean, you could do it from here or do it from here or whatever. But basically, if you think about it, what I do know is I went from here all the way to here, right? But I'm thinking exponential. So I'm thinking it changed really fast, right? So it's got to be some sort of multiplication. But it went down. So it's probably division, right? So if I take 2187 and divide by 81, turns out to be 27, right? So the point here is if you took 2187 and divided by 27, sure enough, it's giving you 81, okay? But see, you jumped, right? So to figure out what it is that you keep multiplying over and over and over again, you'd have to fill in 1, 2, 3 gaps, right? Because I had to figure out what's going on in 3, got to figure out what's going on in 4, and then eventually get to 5. So that means 1, 2, 3. There's got to be 1, 2, 3 things times itself, some number times itself, that would be the same as 27, right? So we got to figure out what number times itself is going to give you 27. Well, you're multiplying here to get to 27, which isn't that big. You take a guess, like, I don't know, maybe 5. But what's 5 times 5 times 5? Oh, that's 125. That's too big. 4 times 4 times 4, 64. That's too big. 3 times 3 times 3. Oh, that's 27. That's what we're working with here. 3 times 3 times 3. Right? 9, 27. So what does that mean? That means we're really dividing by 3 each time. Right? So you can check it out. If you fill in those gaps, so we took 2187 and divided by 3, right? That's going to give you 729. Right? And then divide that by 3 gives you 243. And if you divide that by 3, oh, look, 81. Divide that by 3, 27. Divide that by 3, no. Divide by 3. Sure enough, there's your 9. Divide that by 3 is 3. Divide that by 3 is your 1. Divide that by 3. You're going to get that 0.3 repeating, right? So now we filled in the gaps. What does that mean? You keep dividing by 3 over and over again. Or you could think of it as multiplying by 1/3, right? Right. So you want to think of it as a fraction 1/3 multiplying by, then you're right back to this world here, or you're dividing by 3. Either way. But now we got to figure out the number out front. But this is coming from the beginning when when x is 0. Okay. But they didn't tell me that. So you're going to have to run this idea backwards, right? So I need 1, 0. Just keep running backwards. But again, remember, if you're dividing by 3 this way, that means you should be multiplying by 3 backwards. So if I took 2187 and multiplied by 3, this would have been 6561. Then multiply that by 3 again. This should have been 19683. That's the number that should be here. So 19683. 19683. That's my beginning. So either one of those. Oh, sorry, I couldn't see that. But I basically that's when x is 0. That's enough of that. We'll go up front, right? And see, again, you can check it out. If I did 19683 and multiplied by 1/3 raised to the, say, 2, right? Sure enough, it's giving me that, right? If I did that same thing, starting 19683 and multiply by 1/3, say, raised to the 10th, sure enough, it's giving me that right answer. Or you could think of it as 19683 divided by 3 raised to the 2. Sure enough, is working, right? Or if I plugged in, say, I don't know, 7. Oh, look, it's giving me 9. It's working. Either one of those would work. So there you go.